Going back to our example, market stock here, you can think about the SPDR. As you can see, when the economy is doing better, a market stock is doing better, well, that's by definition of the market stock. The economy is the market and the market is the economy, definitely when it comes to the S&P 500, which clearly represents or reflects the US economy. All right, what is T-bill? Here I give a quick example, a quick explanation about T-bill, but we will see that in greater details later on. How did the returns of the high-tech and the energy securities behave? We already discussed that. We saw that energy and high-tech are negatively correlated between them. Rho is negative between them, simply because an energy stock is a counter-cyclical stock. Let's start to calculate the expected return for each and every stock. So let me go back to the table. This is slide number 5. I will go back to this slide again and again. We said that to calculate the expected return, which is the most likely return, what we do is we sum the products of the probabilities and the returns, the values themselves. I want to remind you to go back to the example about the kids in the daycare that I gave in the introductory lecture. This is an example that will reflect many of the things that we will do in this course, like calculating expected return, variance, standard deviation, covariance, and correlation coefficient. So make sure to know those techniques. To calculate the expected return of high-tech, for example, we do probability of 10% times return of minus 22%, plus probability of 0.2 times return of minus 2%, plus probability times value, plus probability times value, plus probability times value. And we're going to do that the same thing for each and every investment. And this is what we get. Expected return is the sum of the returns times the probabilities. We multiply the probabilities times the respective returns, and we sum up everything. The expected return for high-tech is 17.4%. I saved some time and I calculated the expected return for each and every investment alternative here for high-tech market, biotechnology stock, treasury bill, and the energy stock. And I sorted them in this order. As you can see, high-tech is expected to give us the highest expected return. I emphasize the word expected because nothing is guaranteed here, except for treasury bills. That's the only certainty that we have. Only when you invest in a risk-free investment like US government bond, treasury bills, only then you will have certainty. The 8% was given to you all along the time. Regardless of the economy, you will get 8%. That's the only thing that has certainty. Zero risk, risk-free investment, 8% all the time. By the way, if we need to draw the distribution of returns for treasury bills, what you will get is a straight vertical lines. The returns for treasury bills do not move neither to the left nor to the right. They stand at 8% regardless of the economy. In other words, the distribution looks like a straight vertical line. It doesn't move in either direction. It has a zero variance, zero standard deviation. When you see a zero standard deviation, this is the definition of a risk-free investment. There is certainty here. There is no uncertainty, absolutely no uncertainty. You know for sure that you will get 8% return simply because you trust the US government to pay you back your money plus 8% return, regardless of what's going to happen. That's the definition of a risk-free investment: zero standard deviation, zero variance. Here you see the 8% return for T-bills. So high-tech right now looks like a promising investment. It gives us the highest expected return. The question is, what about risk? We as rational investors, we always prefer to maximize the return, and at the same time, we want to minimize the risk. Most people will prefer less risk than more risk, simply because we are risk-averse human beings. We don't want risk. We prefer certainty over uncertainty. At the same token that we want higher return than less return, we also want to reduce the risk, to minimize the risk. Here is the problem. Risk and return usually, in reality, they go hand in hand together. You need to take more risk in order to achieve more return. Usually, when you take less risk, you should expect to see less return. The problem is that because those things are going hand in hand together, but we are trying as rational people, we're trying to maximize the return and at the same time to minimize the risk, this is the trade-off that we're going to deal with. We want to maximize return and minimize risk, but when you minimize the risk, usually you will also get less return. When you're trying to maximize return, usually you need to take more risk for that. So let's measure also the second dimension of risk for each and every investment. Here are the textbook definition of standard deviation and variance. I mentioned that before in the introductory lecture. We saw that standard deviation is the square root of variance, while the definition of variance is the sum of returns minus the expected returns, squared both of them, times the probabilities. But for any purpose, I highly recommend you to use my shortcuts. Well, I didn't invent those shortcuts. I wish I did, but I didn't. But trust me, they work and they will save you a lot of time and effort. So feel free to use my shortcuts rather than those standard equations in any textbook. But if you really don't trust my shortcuts, go ahead, feel free to work with those equations. They work perfectly okay as well. So let's calculate the standard deviation for each and every investment. Here is a quick example. Standard deviation of treasury bill is, here I'm using the textbook equation. It's the return minus the expected return. Obviously, the expected return is the same as the return because of the certainty that involves in investing in treasury bills, squared times the matching probabilities. So inside the square brackets, you have the variance, and then I raise everything to the power of 1/2. Mathematically speaking, this is the same thing as taking the square root. Clearly, standard deviation of treasury bills is 0. We already saw that. The distribution of returns for treasury bills look like a straight vertical line. It doesn't move neither to the left nor to the right. It means 0 variance, 0 standard deviation. Remember that both variance and standard deviation measure the dispersion of the distribution, how widespread the distribution is. And when you have a distribution that looks like a vertical straight line, distribution is 0, 0 standard deviation, 0 variance. You can repeat the same calculations and find out that the standard deviation of high-tech is 20%. For the market, which is the SPDR for that purpose, 15.3% per year. Standard deviation of an energy stock, 13.4% per year. Standard deviation for biotechnology, 18.8% per year. Here you have all the shortcuts that I gave you on the first meeting. Here you have it neatly written. The expected return is the sum of the probabilities times the returns or the values. Variance is expected returns squared minus expected squared of returns. Standard deviation is simply the square root of the variance. The covariance is a measure of correlation between two variables already, between x and y. It is the expected between x times y minus expected of x times expected of y. And the correlation coefficient, this is our way to standardize the covariance, which is the covariance divided by the product of the standard deviations divided by sigma x, sigma y. Those formulas, we developed them in the first meeting, and please make sure to go back to the example about the kids in the daycare and understand how the calculations are taking place. Comments on the standard deviation as a measure of risk. We said that standard deviation is a good measure of risk simply because it measures the dispersion of the distribution. Just remember that this is true only for symmetric distributions, the vast majority of cases that you will ever face. But for asymmetric distributions, it's not true. Just remember that only the left tail of the distribution is a measure of risk. The right tail is not a measure of risk. Let's consider both dimensions of risk and return. You have here the 5 different investment alternatives, starting from treasury bills, high-tech, energy stock, biotechnology, and market stock, the SPDR. In the next column, you have here the expected returns. Once again, just remember that for treasury bills, this is not expected. This is with certainty. For everything else, those are just expected. Nothing is guaranteed. And here you have the dimension of risk. measured by the standard deviation. So T-bills has 0. This is by definition, but you can also calculate it if you wish. And all the other standard deviations. Just to let you know, once again, our goal as investors, we're trying to maximize return, try to pick the stock that gives you the highest expected return. But at the same time, we as rational investors, we're trying to minimize the risk. So at the same time, try to pick something that will minimize the risk, will give you the lowest risk. As you will see, this is not a simple task. So for example, if you're trying just to minimize the risk, T-bill gives you the lowest risk. But unfortunately, the return is not that great. High-tech, on the other hand, gives you a much higher return, but unfortunately it also gives you much higher risk, higher standard deviation. This is exactly the problem that investors face. So let's see what can we exclude from this table. What does not look like a good investment? Let's focus on energy. Energy doesn't look like a very good investment because it gives you a fairly low return and at the same time a fairly high risk. So let's see if we can find something that definitely beats energy, but pay attention that we need to find something that beats energy on both dimensions at the same time, simultaneously. It's not enough to say, look, high-tech gives you higher expected return than energy, so that's it. No, high-tech also gives you higher risk, higher standard deviation. You want to find something that gives you higher return and at the same time lower risk. So in this example, we can see that T-bills beats energy on both dimensions at the same time. Treasury bills give you higher expected return, 8 versus 1.7, and at the same time lower risk, 0 versus 13.4. So if you need to choose only one out of this table, only one investment alternative, definitely T-bill is better than energy, so you can exclude energy. What about biotechnology? Biotechnology doesn't look like a very good investment either. Why is that? Take a look at that. Market gives you higher expected return than biotechnology, and at the same time lower risk, lower standard deviation. So if you need to choose just one between biotechnology and market stock, definitely go with the market. Do not pick the biotechnology. So we can exclude this investment. We're still left with 3 investment alternatives: treasury bills, high-tech, and market. Now we cannot really exclude any one of these. Why is that? T-bills, it's true that it does not give you too much return, but it gives you the lowest risk. You won't be able to find something that gives you any less risk than that, than 0. 0 standard deviation, that's our definition for risk-free investment. That's the safest that you can get. So you won't be able to beat it on this dimension, the dimension of risk, and therefore T-bill is a very valid investment. High-tech, it's also a very valid investment. It gives you the highest expected return of 17.4, so you will not be able to beat it on that dimension of expected return. You cannot find something that gives you more expected return than high-tech. So that's also a valid investment. What about market? Well, the market gives you some sort of a middle expected return and a middle risk. So it's also a perfectly valid investment. You cannot say that high-tech is better than market or treasury bills is better than market. So all 3 investments, T-bills, high-tech, and market right now look like a fairly good investment. The question is why some people pick treasury bills, others pick high-tech, and others pick the market. It all depends on our risk aversion. We should all agree that human beings are risk averse. We hate risk in general. But the thing is that some people hate risk more than others. Some of us are very risk averse. We really hate risk, and we will pick the T-bills simply because it gives you a risk-free investment with no risk at all. Those people are willing to take no risk in order to get less return, but they are okay with that. Other people are less risk averse. They perhaps will pick high-tech that will give you more risk of 20% standard deviation per year, but also the highest return, highest expected return. Other people may choose market return simply because it gives you some sort of a middle risk and a middle return, and it's perfectly okay with that. We as human beings are rational human beings who are all risk averse, but we're risk averse to different degrees, and that's perfectly okay. Therefore, different people can pick different investment alternatives. One quick method to combine the two dimensions together is called the coefficient of variation. Coefficient of variation, or CV, is simply the ratio between the standard deviation and the expected return, the mean. Just remember that we as rational investors, we're trying to reduce the standard deviation, reduce the risk, hopefully minimize it. So the lower the numerator, the better it is for us. At the same time, we're trying to maximize the expected return. We're trying to maximize the denominator. So higher denominator, the better it is. Both of them are working in the same direction. We want low numerator, we want high denominator. So overall, the lower the CV, the better it is. The lower the coefficient variation, the better it is. Let's try to calculate the coefficient of variation for each and every investment alternatives here and see what do we get. I just have to warn you that the coefficient of variation for treasury bills will be 0 by definition. Why is that? Because you have 0 standard deviation. That's the definition of a risk-free investment. So regardless of the expected return, even if the expected return is 1,000,000% or 0.001%, regardless of that, coefficient of variation for treasury bills will be 0 just because you have 0 in the numerator. So it's kind of useless to calculate coefficient of variation for treasury bills. We will do that, but then we'll have to exclude it from our calculations for the coefficient of variations for the other investment alternatives. Let's do that. Coefficient of variation for T-bills is 0 by definition. For market, it's 1.02. For high-tech, 1.149. Biotechnology, 1.362. And for energy stock, 7.882. Just remember that for T-bill, coefficient of variation is 0 by definition, so we should exclude that. But for all the others, we should pick the one with the lowest coefficient of variation. So right now, the market stock, or the SPDR, the ETF on the S&P 500, looks like a very promising investment because it gives us the lowest CV among all the other investments, excluding treasury bills. Here I want to remind you about different examples when standard deviation is not a very good measure of risk, and what can we do in this case. So here is an example about two stocks, stock A and stock B. A has the red line here and B has the pink-purple line for the distribution of returns. As you can see here, what I did in the PowerPoint, I just created this line and then I just did copy and paste with a shift to the right to create the distribution of returns for stock B. So in fact, both of them have the same variance. As you can see, the left-hand side is far away from the right-hand side for stock A, exactly as the left-hand side for stock B is far away from the right-hand side, the right tail of the distribution of stock B. The variance are the same, and therefore the standard deviations are the same. Sigma A is equal to sigma B, but clearly you cannot say that they have the same risk. Obviously, you can see that on the horizontal axis are the rates of return. You can lose money only with stock A. With stock B, you cannot even lose money. Stock A goes to the left of 0, and these are the negative returns, the loss area. Only when you invest in stock A, you can lose money. With stock B, you cannot even lose money. So clearly, stock B is preferable over stock A as an investment, despite the fact that sigma A is equal to sigma B, or variance A is equal to variance of B. In this case, we can clearly use the coefficient of variation to combine both dimensions of risk and return. Simply because the expected return of stock B is located here to the right of the expected return of stock A, simply because of that, the expected return of B is higher than expected return of A, and therefore the coefficient of variation of stock B is lower than the coefficient of variation of stock A. They have the same numerator, the same standard deviation, but higher expected return for B. Then for stock A gives you a lower coefficient of variation, and the lower the better, and therefore this method shows you that stock B is preferable over stock A. Here is another example why standard deviation is not always the best measure of risk. Let me give you this example. Let's say that you examine two different investment alternatives or two different projects if you want. So project A with probability half will give you minus $2. You're going to lose $2 with 50% chance. With another 50% chance, you will earn $1 here. Project B at the same time with matching probabilities 50% and 50%, you will earn $1 here and $8 here. Without getting into messy calculations, you can see that project B has a higher variance, higher standard deviations. Why is that? Take a look at this distribution of returns. The gap between the left side, the left tail and the right tail is $7. Between 1 and 8, you have a gap here of $7. The gap here is only $3. Between minus 2 and plus, the gap here is $3. So the distribution of returns of stock A is more narrow than the distribution of returns of stock B. Project B or stock B has a higher dispersion. The distribution is more widespread than stock A or project A, and therefore variance of B is bigger than variance of A. Standard deviation of B is larger than the standard deviation of project A. Nevertheless, clearly project A is more risky than project B for two good reasons. One, first of all, on project A you can lose money. On project B you cannot even lose money. You earn money either way. But in addition to that, you can also say that the best case scenario in project A is the worst case scenario of project B. You can earn at maximum $1 on project B, and that's the minimum that you can earn on project B. Alternatively, we can say that in every state of nature, you earn more in project B than in project A. If first event happens with probability half, here you lose $2, here you earn $1. With the second 50% chance, if the second event happens, in project A you earn $1, in project B you earn $8. So it's a no-brainer. Obviously, you should invest in project B rather than in project A. Clearly, project B is less risky than project A, despite the fact that standard deviation of B is higher than standard deviation of project A. Once again, I'm showing you those examples just to make my point that, first of all, look at the problem, look at the numbers, use your common sense. Try to figure out, does it make even sense to consider the other investment alternative? Then and only then, once you use all of your common sense, then try to plug in the numbers, use the statistical method, the mathematical methods, and try to figure out which one gives you the better return and or the less risk.